Welcome to another deep dive. Today, we're tackling a really big question, one that, well, it trips up a lot of people just starting out with astronomy.
It really does.
You're excited, you're ready to explore the cosmos, you decide, okay, time to buy my first bit of gear, and bam, you hit this wall. Telescope or binoculars. Which one do you actually start with? So let's unpack that today.
Sounds good.
Because, one promises these amazing close-up views, that real zoom-in experience on planets maybe. The other gives you this wide, sweeping look at the stars, like the whole Milky Way laid out. But which one is genuinely the right first step for you as a beginner?
That's the million-dollar question, isn't it?
Exactly. Our mission here is to cut through that confusion, help you make the choice that fits. Because honestly, getting this right, it could be the difference between finding a hobby you love for life.
Sure.
Or ending up with some expensive kit gathering dust. And, the answer might actually surprise you.
It often does. It's such a fundamental decision, and it really shapes your first impressions of stargazing. Getting bogged down by the wrong equipment early on is probably the biggest reason people give up.
That's spot on. So much frustration potential.
Understanding the pros and cons now, before you spend anything, can save you that headache and hopefully keep that initial spark of wonder alive.
Okay, so let's dive right in. Many experienced astronomers, interestingly, point towards binoculars as the ideal first instrument.
They do, and for good reason.
I kind of like this analogy. Learning the sky with binoculars, it's like learning to drive an automatic car.
I like that.
It's intuitive, pretty easy, and it lets you focus on the road or, the stars in this case, not on fighting with the clutch.
That's a perfect analogy. It really captures the essence of why they work so well for beginners. The main goal initially should be sparking curiosity, right? Not immediate overwhelm. You want to build a connection with the night sky, learn your way around. Binoculars are just brilliant at that. They offer this accessible, immediate reward. The learning curve is just gentler, much more enjoyable.
Yeah, they remove so many of those initial hurdles.
Absolutely, just getting out and looking up becomes easy.
It really does. So let's talk specifics. Advantages. First off, basically zero setup time, and they're incredibly easy to use.
Huge plus.
You just take them out of the case, point them up, and look. That's it. No fiddling with mounts in the dark, no complex alignment procedures. What you see with your eyes, boom, instantly magnified.
It's direct, intuitive, fast.
And that ease of use, expert, it's more than just convenience, isn't it? It actually affects how often you'll observe.
Massively. If grabbing your gear feels like a chore, you just won't do it as often. Binoculars almost invite you to take a quick peek, even if it's just for 5 minutes.
Totally agree. The best scope is the one you use most, right?
Precisely. And binoculars often win on that front, especially at the start.
Okay, beyond simplicity, there's what I'd call their superpower, that wide field of view. Binoculars show you a really big chunk of the sky all at once.
Crucial.
Why is seeing such a big area so important when you're just starting out?
Well, think of it like learning a new city. You wouldn't start by just staring at one single building through a peephole, would you?
No, probably not.
You'd want a map or maybe a view from a high point to see how the streets connect, where the landmarks are. That wide field in binoculars is your celestial map.
Okay. Makes sense.
It helps you see the constellation patterns, how they fit together. You learn to navigate by star hopping, using brighter stars you recognize to find dimmer things nearby. It's a fundamental skill.
Right, it builds that mental map of the sky.
Exactly, a skill that stays with you even if you get a big telescope later. Binoculars provide that essential navigational foundation. How do you explore if you don't know where you're going, right?
Right, good point. And then there's portability and versatility. They're the ultimate grab-and-go scope.
Absolutely. Lightweight, compact.
You can chuck them in a backpack for camping, take them hiking, or, like you said, just pop outside for a quick look if the clouds break. Super easy.
And they're not just for night. That versatility is a big bonus. Great for bird watching, spotting wildlife, checking out scenery.
Yeah.
You get more use out of them.
True. Daytime use is a definite plus. Which brings us to cost. Affordability.
Yes. Always a factor.
You simply get more optical quality for your money with binoculars, especially compared to telescopes at that entry-level price point.
Definitely. A really decent pair of astro binoculars, say a standard 10 by 50 size that's 10 times magnification, 50 millimeter lenses.
Yeah.
That might cost you, what, $100, maybe $150? A telescope for that price is often, well, problematic. Binoculars give you much better bang for your buck initially.
So let's talk about what you see. If someone gets a good pair, like this 10 by 50s, what are some of the first wow moments they can expect, beyond just seeing, more stars?
Oh, okay. First up, the moon. It's absolutely stunning. Forget just a bright disk. You'll see thousands of craters, the vast dark seas, the Maria, those old lava flows, mountain ranges casting shadows. It looks almost 3D. Really impressive.
Wow. Okay.
Then on a dark night, away from city lights, just sweeping through the Milky Way, it's unforgettable. You go from seeing a faint, hazy band to resolving these dense fields packed with uncountable numbers of stars.
Sounds amazing. What about those deeper sky objects, nebulae, galaxies?
Yeah, you can start spotting some classics. Large, bright star clusters are fantastic in binoculars. The Pleiades, M45, the Seven Sisters, gorgeous. The Beehive cluster, M44, same thing. Often they're actually too spread out to fit nicely in a telescope's view.
Ah, interesting.
But in binoculars, they fill the view beautifully. And you can definitely find the Andromeda galaxy, M31. It'll look like a small, faint, oval smudge of light. But hey, that smudge is another galaxy 2.5 million light years away.
That's incredible, seeing another galaxy with just binoculars.
It really is. And the Orion Nebula, M42, in the winter sky, clearly visible as a fuzzy patch below Orion's belt. You can start to see hints of its shape.
Okay, cool. What about planets? Can you see much detail there?
Well, detail is tricky with binoculars, but you can definitely see them as planets, not just star-like points. Jupiter is the star here.
Oh, yeah?
You can easily see it as a distinct little disk, and the real thrill, seeing its 4 largest moons, the Galilean moons, Io, Europa, Ganymede, Callisto, they look like tiny little stars lined up right next to Jupiter.
That's awesome, like recreating Galileo's discovery.
Exactly. It's a genuinely cool thing to see for yourself. So yeah, binoculars reveal a surprising amount.
Okay, so binoculars sound pretty fantastic, which leads to the obvious question.
The what?
Why does anyone even buy a telescope then?
Fair question.
If binoculars are so great, what's the point?
Well, the point is detail and faintness. When you're ready to move beyond just exploring the neighborhood, let's say, and you want to really zoom in on a specific distant address in the cosmos, you need a tool with more reach, more power. Telescopes are for when you want to get up close and personal with individual objects. They're about that deep dive into specifics.
Right, so it's a shift from broad exploring to detailed observing.
Precisely. A telescope is a more specialized instrument. It lets you scrutinize things to see features that are just, well, invisible in binoculars. It's about gathering more light and magnifying the image much more.
And that high magnification, that's the main draw for most people, right? That's why they think telescope.
It is. It's the headline feature. The ability to magnify significantly more lets you see things like Saturn's rings distinctly, or cloud bands on Jupiter, things impossible with typical binoculars.
But you mentioned something else. Light gathering, aperture.
Yes, and this is arguably even more important than magnification, though it gets less attention. Aperture refers to the diameter of the telescope's main lens, or mirror the part that collects light. Bigger aperture means it collects more light. Simple as that. Think of it like a bigger bucket collecting more rain. More light means brighter images, and critically, it means you can see much fainter objects.
Ah, so not just magnifying, but making dim things visible in the first place.
Exactly. This is the key to hunting down those faint fuzzies, the dimmer nebulae, the distant galaxies, the fainter star clusters that might just be invisible or barely there in binoculars. Light gathering is the unsung hero.
Gotcha. So bigger aperture is brighter image. Sees fainter stuff. Makes sense. And telescopes offer a growth path too, right? Upgradability.
They absolutely do. That's a major advantage. You can change eyepieces to get different levels of magnification for different targets.
Right.
You can add specialized filters, like filters to cut through light pollution, or colored filters to bring out details on planets. And of course, if you get the bug,
Astrophotography.
Astrophotography. A telescope, especially on a good, stable mount, is your gateway to taking those incredible pictures of space. That's a whole other fascinating dimension to the hobby.
Okay, so let's connect this to what you actually see. Using a decent beginner telescope, say, a popular choice, like a 6-inch Dobsonian reflector. Simple design, big aperture for the cost. What new sites open up?
Right, a 6-inch Dob is a great benchmark, and this is where planets really come alive.
Okay.
Jupiter. You're not just seeing the moons as dots. You'll clearly see the main cloud bands across the planet, maybe even hints of swirling detail within them. And under good conditions, yes, the Great Red Spot becomes visible.
Wow. And Saturn.
Oh, Saturn is breathtaking. You will clearly, distinctly see the rings, not just a hint, not an oval shape, but a definite ring system, separate from the ball of the planet. You might even see the gap in the rings, the Cassini division. On a good night, it's just iconic.
That sounds incredible. What about Mars?
Mars is tougher. It depends on when you look, ideally during opposition when it's closest. But yeah, with a scope like that, you can see its distinct reddish color, maybe make out a polar ice cap as a bright spot, and even see some darker patches on its surface.
Cool. And those deep sky objects, the faint fuzzies.
They get a serious upgrade, that faint smudge of Andromeda in binoculars. In a 6-inch scope, it becomes a much brighter, larger oval. You start to see more of its extent, maybe even hint of its brighter core, the Orion Nebula. It goes from a fuzzy patch to showing real structure. You'll see intricate wisps and tendrils within the gas cloud, brighter regions, darker lanes. You can see the trapezium stars, the young stars lighting it up from within, resolved clearly.
That's a big difference.
Huge difference. And globular clusters, something like Ep.14, the Great Cluster in Hercules. In binoculars, it's a fuzzy ball. In the telescope, it explodes into this stunning, glittering swarm of thousands upon thousands of tiny, individual pinprick stars. It really takes your breath away.
Okay, that definitely makes the case for telescopes. But now, we need to talk about a really crucial warning. Maybe the most important bit of advice, this whole deep dive.
This is critical.
The hidden truth, perhaps. Expert, what's the absolute biggest mistake a beginner can make when choosing?
Oh, hands down, it's buying one of those cheap, low-quality telescopes you often see in department stores or online marketplaces, usually advertised with crazy high magnification numbers.
The hobby killer.
Exactly, the hobby killers. I hear stories all the time. Someone gets one for Christmas, they're super excited, they take it outside, and they see absolutely nothing but blurry, shaky disappointment.
Why are they so bad? What actually makes them fail?
It's usually a combination of two things. Terrible optics, and an incredibly flimsy, shaky mount.
Okay.
The lenses or mirrors are often poor quality plastic, giving you dim, blurry images that just won't focus properly. And the mount, the tripod, and the bit that holds the telescope tube, it's usually so lightweight and unstable that the slightest touch, even the wind, makes the view wobble uncontrollably.
So trying to find anything, let alone see detail, is impossible.
Virtually impossible. You spend all night fighting the equipment instead of looking at the sky. It's intensely frustrating. You quickly conclude either A, astronomy is too hard, or B, there's nothing interesting to see. Neither is true.
Right, so in this specific scenario, comparing good binoculars to a bad telescope.
Oh, there's no contest.
A good pair of binoculars isn't just better than a bad telescope, it's like 1,000 times better.
Yeah.
The experience is night and day.
Absolutely. Let's break it down.
Okay, good binoculars, maybe $100, $150.
Yeah.
You get a bright, wide, stable view. Setup time, 0 minutes. Result, joy, discovery, wanting to go out again. Bad telescope, maybe also $100, $150. You get a dim, blurry, shaky view that's hard to focus. Setup, frustratingly long, often confusing, and ultimately unstable. Result, frustration, disappointment, and a telescope that becomes a closet decoration.
A dust collector.
Yep.
It's a really stark contrast. And it highlights the importance of prioritizing quality over, the idea of having a telescope.
Definitely.
What's fascinating, or maybe sad, is how quickly that bad first experience can just completely extinguish someone's interest. Investing wisely up front, even if it means starting simpler with quality binoculars, it preserves that initial curiosity. It keeps the door open.
That makes perfect sense. Don't kill the hobby before it even starts.
Exactly. Enjoyment should be the priority, not fighting bad gear.
Okay, so we've laid out the cases. Binoculars, telescopes, the cheap telescope trap. What's the final verdict? How does someone listening right now decide which path is right for them?
Ultimately, it really does come down to your personal goals, your current knowledge level, and realistically, your budget.
Right. Let's try and guide people through those decision points.
Sounds good.
Okay, you should probably start with Binoculars If. Number 1, you're an absolute beginner. You don't know constellations yet. You want to learn your way around the sky first. Binoculars are perfect for that.
Agreed. Foundational learning.
2, your budget is, say, under $200, maybe $250. At that price, quality binoculars will give you a much better optical experience than any telescope you could buy.
Definitely better value in that range.
And 3, you really value portability, quick setup, easy sessions. You want something you can just grab and go without fuss. Binoculars win there.
Yep. Grab and go simplicity.
Okay. On the flip side, you should probably start with a telescope if. Number 1. You already have some familiarity with the night sky. Maybe you know a few key constellations. You can find the North Star or the Moon easily.
Having that basic navigation skill helps a lot with a telescope.
2. Your main goal, right from the start, is seeing details on the planets. You really want to see Saturn's rings clearly, Jupiter's bands. That's primarily telescope territory.
Planetary detail needs magnification and aperture.
3. You're specifically excited by the challenge of hunting down those fainter deep sky objects, galaxies, nebulae, dimmer clusters. That's where a telescope's light-gathering power really comes into play.
That faint, fuzzy hunting.
Right. And crucially, number 4, your budget is higher. You need to be prepared to spend at least, realistically, $250 to $300, maybe more, to get a quality beginner telescope, like that 6-inch Dobsonian we mentioned. That's kind of the entry point for a good experience.
That budget point is really key for telescopes. Below that, you risk falling into that hobby killer trap again.
Exactly, so be honest about those points.
And I'd add one more thing. Be honest about your own patience and learning style.
Good point.
Telescopes, even simple ones like Dobsonians, do have a slightly steeper learning curve than binoculars. Finding objects, using the finder scope, understanding eyepieces. It takes a little more effort initially.
Sure.
So the right choice isn't just about specs. It's about what matches your enthusiasm and minimizes frustration for you. Pick the tool that you think you'll actually enjoy using the most right now. Start successfully, build confidence.
That's great advice. Remove barriers to enjoyment.
Precisely.
So, wrapping up, there really isn't a single wrong answer here, just the answer that's right for you and your situation.
Well put.
But maybe the most crucial takeaway, the thing we really want you to remember from this deep dive, is simply this. The best instrument, telescope, or binoculars is the one you actually use the most.
Couldn't agree more.
The goal isn't just owning gear. It's getting out there under the stars and looking up. That's where the magic happens.
Absolutely. Which, raises one final question for you to think about. Beyond the binoculars or the telescope you choose, what's the most powerful tool you already have for exploring the cosmos? It's your own curiosity combined with access to a reasonably dark sky. Feed that curiosity, find those dark skies, and you're well on your way. Happy stargazing.